Hello everyone, this is Arpit. I am a software engineer and I have worked for several big tech companies developing APIs, multiple of them from scratch. I've been in this field for around 7 years now, so I've been in those situations where I had to look at different API technologies available, consider trade-offs, and then select the one which is best suited for my use case. So for this talk today, what does being RESTful mean? It doesn't really mean that you shouldn't use REST. REST is really popular and for good reasons, so you should definitely consider it as one of the options for your use case. But what we mean by don't be always RESTful is you shouldn't be lazy. Don't be lazy and use REST just because it's the default thing to do. You should look at other alternatives and then select the one which is best suited for your use case. As an alternative, we'll cover GraphQL and gRPC today. And at the end of this talk, you should have a general idea of different trade-offs to consider when selecting an API technology. And spoiler, it does really depend on your use case. We cannot really generalize whether REST is a better API technology, GraphQL, or gRPC. They're all suited for different use cases. So based on a use case, you might want to use GraphQL, gRPC, or REST, but it really depends on your goal and requirements. So to get started, Ritika, why don't you provide us some context about what is REST?
Thank you, Arpit. Hi, everyone. My name is Ritika. I'm also a software engineer and I've worked on many APIs, some RESTful, others not. And I'm here to share my perspective about why you shouldn't always be maybe RESTful. So, like Arpit mentioned before, let's take a really quick look on what really being RESTful looks like. This is, in my opinion, a typical case of a server client architecture. On the right hand side, you have your server, and on the left, you have clients. These clients can be of very many different nature, and this is what typically you're expecting, right? Your client is sending a request, and on the right, you have a server that has some items that probably need to be sent or they're probably stored, and then the client like searches them and then sends them to you back. And in the middle, what you really have is the restful part of it, where you have a resource, you have an API, uh, and these resources, note that they're not commands, but they're resources that can be managed, updated, and reused. What that means is this makes REST reliable, faster, and scalable. You can keep asking for the same resources again and again. You can manage them, which means you can update them. And finally, if you have different clients asking for the same data over and over again, you can also start to reuse your resources. Um, let's see how we got here, really. What made us invent REST and probably have like all of the world use it. So back in the day, probably I wasn't even born. At that time, we were really having just binary protocols. These were protocols that were bound in language. And imagine this situation with me, if you can. You are on um, you're in an airline terminal, like you're trying to catch a flight, and there's a software. It's a black screen. It's probably written in C, and you can type in commands, and it's able to fetch the customer data and have you go on board the flight. And in this case, your client is this terminal which is sitting in an airport across the world, but your database could be somewhere totally different miles away. And uh, what forced back in the day was that what was forced is that your server and your client, they both had to be talking to each other in the same language. So your packet was extremely precise, right? Your client was making these specific calls, and your server was answering exactly the questions it was asked in the same language as it was asked in. And you can imagine this was really inconvenient for developers because yeah, like, I mean, we came up with mobile phones and then different like headsets and whatnot really quickly. And so this was obviously not a solution going forward. So we thought we should do better, and we did. We came up with Corba. Corba is Common Object Request Broker Architecture. This honestly was all of our engineering's first effort to create something that looked RPC like, remote procedure call like. In this case, you really got rid of the dependence on the language, which means your architecture now is language agnostic. Perfect, great. Your app in your client side could be in any language. Your server could be in totally other language. But however, this architecture was still very tightly coupled in the sense that it was synchronous. Excuse me. That means every time you could make code changes on the server, you had to make a corresponding code change in the client. That means the client developers are constantly trying to synchronize with the server developers, and that is not easy. Most of us probably know that. This synchronization was beyond development, actually. You even had to deploy at the same time, because there's no concept of backward compatibility here, right? Like, you're sending a packet, you're making a specific request, you're getting a specific response back. So even if you're adding a new field, you suddenly want to start recording the zip code that the user lives in, and now you want to send that data back to the clients. All your clients have to go back up. In fact, at one of my jobs, our database was written, and it was using Corba to send responses from the database back. That means every single time we had an update to our schema, we had to tell our users that, hey, we're in server downtime mode right now, and please come back later. And that made our service effectively unusable for that little bit. Not to mention the amount of effort we spent synchronizing with the client teams to make sure that the changes were being rolled out all at the same time. So we wouldn't go back up live until deployments were successfully done both on the database server and the different clients that we had. We had a web app, we had a mobile app, and whatnot. So, of course, we all said, hey, we need to do better, and that's how we arrived at SOAP. SOAP is Simple Object Access Protocol. The premise is basically similar as Corba is. Small changes on any side of client and server needed everybody to upgrade to the new requirements. And just like Corba, the packets were extremely precise. That means you were only getting in sending packets which contain information you really needed to send. The difference, however, was now you were talking in XML. That means it was easier to parse compared to serialized bytes and whatnot. We said we can do better, and we came at REST. From the 90s, we jumped to the 2000s, and now we have representational state transfer. Again, your app and server can be in any language you want, but really what we've created is a stateless service, which means you don't need to remember what was the last thing you sent. And your client has the ability to ask for any resource at once, which means your server can have endpoints which represent different resources that are available for the client to consume. And the best part is the server can send any media type back that it wants. This was perfect. We were streaming more videos, we were sending more pictures, social media coming up and whatnot. And everybody was talking the same language. Like, clients were saying, get this, post this, delete this, put. So, like, with a consistent language and consistent architecture, number one, your URIs are your resources, and the browser knows it has to request a resource, and the format that it got the response back in was fixed. You knew you had to expect a header. You knew there was a body. You knew how to read headers. They were all in a typical fashion. And there was a clear boundary now that was being established between what is a server and what is a client. And the best part is any response was cacheable. That means if your client predicted that the same information would be useful in the future, it could just save a copy. REST was great. This is how we really built so many of our software functionalities today, and it's great. But believe it or not, 2000s was 20 years ago. So I think REST is still history. Let's move on to the new shiny stuff.
Okay, so rest is history. Then what do we have now? We have several alternatives to rest. We'll talk about two popular ones today, GraphQL and gRPC. And this shift from REST, I think, is very similar to the shift from SQL. Did we stop using SQL? No. I personally have developed a new service which uses SQL as its database. With NoSQL, we just have more options. We still use SQL and we have more options from NoSQL world. Depending on our use case, we select the one to use. And we should do something similar for APIs. We shouldn't just use REST, but look at other alternatives and then probably use REST if it's the best for your use case. Otherwise, use one of the alternatives. So let's look at these alternatives. Let's start with the first one, GraphQL. Let's take an example to actually understand GraphQL better. So let's take an example use case of newsfeed page on your social media platforms. All of them have a list of posts and then their related info like comments, likes. How do we get all the information to show the newsfeed page on the front end? In RESTful world, the front end, the client will make a backend call, API call to get all the relevant posts. And then another call to get likes reaction for each post. Then another one to get the number of comments for each post. Another one to get all the popular comments, author info, likes, and so on. So we'll be making a lot of calls one after the other. Some of these calls can be made in parallel, not all of them though. And then these round trips do increase or add up to the latencies, right? So how does GraphQL help in this case? In case of GraphQL, you can make just one call and get all of that information. So I'm not saying that you should get all the information in one call, but you could. In case of GraphQL, front-end developer makes that decision on what to get in one call. It is possible to get all the information about less number of posts, show them, and then follow up with more information about other posts that are shown later down on the page so user can probably wait for them. Or we can get basic information about more posts, so show the posts and then follow up with more detailed info like likes and comments later. So this decision is important because on what to get is important because it affects the user experience. And this decision will now be made by the front-end team who's much closer to the user experience. And if your website changes, the view on the website changes, there might be a different set of optimized calls that are better to do. So it's easy for the front-end team to make those changes. So GraphQL is based on the idea of serving a graph of data, which is a set of objects that are associated to each other in some manner. A GraphQL API becomes more powerful as more related data objects are served through it. So GraphQL stands out from other API technologies as it allows the client to get exactly what they want, nothing more and nothing less. For example, client can get info about post or info about post plus author or any other permutation of objects that are related directly or indirectly in this graph. How is that possible? What brings in that flexibility to GraphQL? This is possible through something called a GraphQL query. In case of GraphQL, we have just one endpoint. And the query that you send as the body of the request decides what response you'll get. What data do you want to get? In case of the first example, I'm trying to get just the name of the country. And then on the right side, we get a response with just the name. But if I need the currency of this country as well, and if the backend has that information, then we'll get currency as well. So this is an example how queries help you help the client get exactly what they want. But this is just selecting a specific field from single object. GraphQL's power comes from getting multiple objects at the same time. How do we do that? It's also possible in a very similar manner through queries. On line 5 of the request, we are trying to ask for continent, which is an entirely different object, and we're getting the name of the continent. On line 7, we are getting all the countries that are associated with the continent, all of that in one go. So we are able to get one country information, its continent, as well as all the other countries in the same continent. So this flexibility provided by GraphQL queries is what makes it so powerful. So moving on to gRPC, Ritika, on to you.
That, let's look at gRPC. And I would really like to tap into Arpit's example from earlier. So let's say you still have a newsfeed, and this time I'm using REST to ask for a specific endpoint, I guess. So let's say your newsfeed wants to display 10 posts. So it says, hey, get me 10 posts from the server. You're scrolling, and so you say, hey, the user is reaching the 10th post, get me 10 more. So you say, get me next 10. Next 10. We all have our days when we're scrolling. And so you keep getting the next, and the next, and the next. Do you notice a pattern? Like every single time your client needs certain posts, it has to make a request and then get a response back, parse it, present it in the way it's supposed to be presented on the client side. This is a lot of work. Wouldn't it just be easier to keep having the posts coming until I say so? That's exactly what gRPC is. You say, hey, I want a stream of posts back to me. So gRPC honestly just allows you to for your client to send one or more requests, or have your server send one or more responses. So there's a connection that opens up, and you can send as many packets as you want in between. So you could have a unary, typically just like REST. You have a client, you have a server, you're just sending one request, getting one response back. That would be a typical architecture. But gRPC really allows you to do server streaming, client streaming, and even bi-directional streaming, which is great. Now, even in gRPC, the client server are very tightly coupled. That means you have a specific language you need to talk to each other in. That is the protobuf. Protobuf is like serialized bytes. So you define like a message. We use that a lot at work, and all it is like fields next to each other. You can fill up as many fields you want, and then serialize the whole thing and send it across the wire. The great part about protobufs is that you don't have to write a lot of code. You can just define what the proto looks like, and then have a compiler which generates that code in many different supported languages, which is fantastic. Now, the best part about how gRPC is related to REST is they're both mechanisms to exchange data, and they both are using HTTP. Specifically, gRPC is designed to use HTTP2, and allows you, again, to be as language agnostic as possible. And another great thing is, just like REST, it is asynchronous, and it is stateless. That means, again, you don't need to have context before you make your next request. It could be two totally different requests. Let's look at use cases. How are we gonna use one over the other?
Now we've looked at some alternatives to this. Let's look at some use cases and decide which API technologies would be best suited for each of them. Let's start with, what if we have multiple data sources on the backend? And these data sources could be a database or a different service. What do we do in such cases? We can probably use GraphQL to provide a well-connected picture to the client instead of sending out disjointed set of objects. And on the back end, we can probably be using REST or gRPC to actually communicate with these multiple services. Moving on to the next use case, what if there are multiple frontends and each needs same data but probably in a different view? And most of the applications are like that these days because you have a web application as well as a mobile app. They provide the same information but have different views, and because of that, they might need a different view of data from the backend, or different view of data might be more optimized for each of these. In such a use case, GraphQL is a good option to consider because on the client side, the web app or the mobile app can decide what information is needed, what information is needed first, and what can be provided later.
I'm gonna make the case for gRPC. Next time, honestly, you're thinking, what should I want to be used? I want you to imagine me, picture me, and think about the use cases I'm gonna talk now, and see if gRPC makes a good fit for what you're trying to do. Uh, so we come back to our case where you have a client and a server, and you're streaming a bunch of data in between. gRPC is the answer. So you could have, you know, a client which is seeking multiple responses from the server. A really, really great example of server streaming would be video streaming. You have a client that says, hey, I need to play this, I don't know, many gigabytes of video for my user. So why don't you keep the packets coming and I'll tell you when to stop. This is a perfect example of server side streaming. Multiple requests. So you want, as the client, to keep uploading and multiple packets, and your server accepts them all and then at some point responds back saying, hey, this looks good. A great example would be you have a software on the server side to just store data. So you could just have a blob storage, for example. And so you have your client sending multiple bytes of packets, each which contain your user data that needs to be stored on the cloud. And your server is just accepting those packets and in the end acknowledging that it has successfully indeed saved. Finally, the bidirectional streaming. So we arrive at multiple requests, multiple responses. You'll have your client sending requests. At some point, you'll have your server sending responses, and they just like continually talk to each other. So it's not necessarily predefined how many packets go in which direction. Great example is a chat app. Your client is just sending data and receiving data at the same time from the server. So imagine me chatting with you. I'm sending packets from my machine. The server's receiving them, and while I'm typing, your client is typing somewhere and sending packets which I am receiving continually, and this is like what an open connection between me and the server looks like. So let's talk about which one to use.
So we've looked at some use cases on when to use each. Let's try to generalize when does each API technology shines. And keep in mind, this is more or so a guideline than rules. It really depends on your very specific use case. So let's start with GraphQL. When do we use GraphQL? I think when you have highly related data objects, when your objects are related to each other and you want to show a connected picture to the client, GraphQL might be a good technology to use. GraphQL is really good used as an aggregator or a gateway when you have multiple data sources behind the scenes because it helps the user get a connected picture. And lastly, when you have multiple clients or you have multiple different views which need similar data but just in a different format.
The case for gRPC is when you have a lot of microservices and you want to communicate between them, gRPC is your answer. Your API is extremely latency sensitive. This is great because in gRPC, you're using protobufs. Your responses are serialized. You're not sending any extra data. That means your packet is concise, precise, and you don't have to depend on your user's amazing network always to have the best possible speed. And of course, the last case is streaming.
So when do we use REST? You should consider REST if your data is independent and your use case is simple. REST APIs may be the best in such cases because they are usually the simplest to build, and most of the people already have tooling to be able to build REST APIs. Secondly, if your client has some constraints on what they can use, they should mostly be okay with REST. Or if they are not willing to learn a new technologies, in practice, sometimes you have to go with what the client needs. And lastly, let's face it, REST is still default. It's really popular. If you're not able to select a different API alternative, REST could still be a good option to choose. So let's recap and look at the API technologies. Taking the same example of country information that we use for GraphQL queries explanation, let's see how it would look like in different API technologies. In case of REST, it would look something like this, where you make one API call to get country information, and then you make second get API call to get the continent of that country. In case of GraphQL, instead of two calls, you can get all that information and probably even more in just one call. And instead of making a call to different endpoint, you make a call to the same endpoint, but you provide a query which defines what response you want, what data you want. And lastly, in case of gRPC, we'll make a remote call and data returned will not be serialized into a human readable format like JSON. Instead, it will be a more optimized machine readable format, saving on amount of data to be transferred over the network. We can use any of these API technologies in most cases, but which one is most optimized for your use case depends on your goals and requirements. And let's be clear, it's not really about being wrong versus right in most use cases. It's about which API alternative or which API technology is most optimized for your use case.